In this example, we are given the right angle of a triangle, one of the side lengths, and one of the angles associated with the triangle. Our goal is to finish solving the right triangle. So first things first, I'm going to organize my data in the following fashion. So 3 sides together, 3 angles together. Gamma is our right angle in this case. We were told that beta is 10 degrees, and that B is a side length of 4. Now with this in mind, the order in which we do these things, there's a little bit of freedom to it. First thing that I notice is since I have 2 of the angles, I can find the third angle. So I'm going to say let's start by finding alpha, using the fact that alpha and beta are complementary. So alpha plus beta is going to be equal to 90 degrees. Plugging in what beta is equal to, that'll be alpha plus 10 degrees is equal to 90 degrees. Therefore, alpha is going to be equal to a total of 80 degrees. Every time I find something, I'm going to head back up here and fill in that piece of information that I just found. Now at this point, I want to start getting other sides. Now if I have a side and I know an angle, I can use a trigonometric ratio to get another side. For example, if I wanted to find A, then I would need to relate A and B with either alpha or beta. For lack of a better idea, I'm going to go with beta on this one. Now, from the perspective of beta, B would be the opposite side and A would be the adjacent side. So I'm going to find A using the fact that the tangent of beta is equal to the opposite side, B, over the adjacent side, A. Because I know 2 of these quantities, I can solve for the third one. So with that in mind, I am going to plug in the values that I currently have. Tangent of 10 degrees is equal to B, which is 4, over A, which is currently unknown. To solve for A, I'm going to multiply both sides by A and get A times the tangent of 10 degrees is equal to 4. And finally, divide both sides by the tangent of 10 degrees. If you're looking for the exact value, you now have your final answer. A is equal to 4 divided by the tangent of 10 degrees. However, because we're going to be dealing with some application problems, you might want to get an approximate answer as well. So with that in mind, check to make sure that the calculator is in degree mode rather than radian mode, which mine is, and ask the calculator for 4 divided by the tangent of 10. It'll now assume that that means 10 degrees. So if we want to approximate our answer, that'll be about 22.68, and I'm going to put an insignificant 51 after that. So for example, if a final answer says to round to the second decimal place, we would say that this is 22.6. After the 8 is a 5, so we would round that up to 9. Now, if I need to reuse A in another calculation, I really don't want to use the rounded answer, so that's why I carry a couple extra decimal places in case I have to reuse it. Now, what I mean by that is I could reuse B and use another ratio to find C using a similar technique, or because I know 2 sides, I could also apply the Pythagorean theorem. So what I'm going to do is demonstrate that I could do either of those and have it work out okay. So if we go a squared plus b squared is equal to c squared, then we could say that 22 point, and I'm going to use my elongated rounded answer rather than my shortened rounded answer. We don't want to round too much this early in the process. I'm actually going to use the version that I had for my calculator. I'm just going to square this. I'm going to get that that number is about 514.61. Because of all those 9s there, we'll round that off to 5, plus 16. That'll be c squared. Now adding those numbers together gives us about 530.615. That's, again, c squared. Then I can take the square root of that answer. Square root, second followed by the negative sign, lets me type in answer. And I'm getting that c is approximately 23.03, and then an insignificant 51 after that. So if I wanted to reuse this for another calculation, I would hold on to the 5-1. But if I wanted to round at the second decimal place, I would call that 23.04. Now, with those things in mind, I could also find c by using the exact value 4 and some other trigonometric ratio. From the perspective of our angle beta, I notice that b is the opposite side and c is the hypotenuse. So I could also relate them by pointing out that the sine of beta is equal to b over c. If I plug in what I do know, I can solve for what I don't know. So sine of 10 degrees is equal to b, which is 4, over c, which is what we're trying to solve. Multiply both sides by c, similar to what we did above. We get c times the sine of 10 degrees is 4. So c is equal to 4 divided by the sine of 10 degrees. So with that in mind, going back to the calculator, if I perform this calculation, 4 divided by the sine of 10 degrees, you'll notice that we wind up getting the same result. So do be sure to hold on to your rounded answers a couple extra decimal places so that you won't run into any rounding answers for your final answers.